Okay, I come from the corporate premises at BBVA, who's becoming a data-defined bank. So we, in the facility management department, have decided to use the same philosophy for the facility management. Okay. So we wanted to use all the data, all the information that's around us, and make the most of it to manage the buildings. So the idea is to build a data model with the building. So we're using two different tools, BIM and Building Analytics, to manage and organize all the information. Okay, BIM. You know BIM, but I have to say that BIM is not only a beautiful 3D model that's used for design and construction. It can become a useful building database for FM. First, it can help avoid the loss of data from the construction phase to the FM phase. And the most important thing is it can become a single, unified, and always updated database for the building. Okay, what are the keys for BIM during the FM phase? First, we have acknowledged that the adoption of BIM must come from the owner. We have been using BIM for some years, but until recently, we haven't made ownership of the models, of the concept, and the ways of work that can bring you. In our case, we decided to implement BIM into our department or area. And so we started by creating a team that's going to manage the models, the database, also a small BIM committee who's going to make the decisions about what are we going to do with BIM, what are we going to extract from it. We implemented some tools, software, hardware. Some were free, some had costs. And the important thing is to create and maintain the procedures and requirements. Procedures define how we're going to use BIM, and the requirements define what are we going to ask for third parties, to do in BIM for us. It's important it's important to say that we have developed our own procedure, and it's defined on our needs. Each owner must think and must define its own needs. Also, that BIM has been around us for some time, but still has some way to go. So the procedure must comprehend also the use of CAD during all this way. But the important thing is that you have to use a universal and scalable format for all your BIM portfolio. At first, we had many models, different BIMs, but they weren't the same. They had different structure. Okay, I made this little picture so to show what I want to how I want to illustrate that. If you look at the first cube, that's the model of the building A. It's the design phase. The model is being created. So at the very early phase, there's only one user, but the user is going to define its own filter. It's like a lens. So you look at the model, it's an abstract group of information, and maybe this user is interested in the design. He needs the information ordered and structured in some way. He needs some drawings, some floor drawings, elevations. He needs some schedules. He wants to see the design of the building. So he defines his lens to filter the information from the abstract model into 2D drawings, 3D representations, tables, reports. Then, so the building advanced to the next phase. Is now the construction phase, the same building, but the model is now more complex, but it uses the same structure. The user one is still using his lens. He's seeing the same kind of information, but now the information is more complete. And now a different user appears. He's more interested maybe in costs, on some aspects of the construction. Maybe he's from the space planning department, and he uses a different lens. Both lenses are compatible with the structure of the model, so they can see different things from the same model. Say we enter in the FM phase, we have the building, it's now complete. A lot of new information is fed onto the model information about the maintenance, cost, materials. So now all this information can reflect into the existing lenses. So you can add user number 3 and any kind of users. So the important thing is you don't have different models for each user. There's one only model, one set of data, and it uses filters the data into concrete representations of that data. Also, you can see different other buildings, buildings B, C, and D. They all use the same structures as building A. So using the same lens, user number 3 can see what he needs, the same reports, the same drawings from each building. So you don't have to build a different lens, a different filter for each building. Well, another key to BIM in FM is that you have to make reviews of the design of the drawings, some comments. So we are trying to do this traceable to make a history of the different review by all the parties with markups on the drawings and on the reports and storing the history of the design. Also, we thought that BIM has to be for everyone. So everyone in the department, in the different areas who work in the building can make use of BIM. Of course, there's a group who is drawer designers. They manage the editable database, but the reports and the drawings and the different outputs are for everyone. So you don't have to instruct everyone in the very difficult methods. So it has to be an easy and useful tool for everyone. That's created by lightweight models. Your model has to be easy to scale. You can start with little, then you use scalability to input more information. And as I said, the most important thing is that there's one model, one database for different uses. So we come to the data. How can BIM be used as a database? First, you have to reflect. What do I want to know and what do I want to communicate? So you start listing what's the information that you want to store or you want to extract from the BIM. You may have another databases, the facility management database, human resources database, and you don't have to repeat the same information in different places. So typically, BIM has served the data graphically as drawings, maybe some spreadsheets. But if you extract, if you can automate the extraction of data from BIM, you can start creating a building data service. You can serve data, of course, to drawings. You can serve data to the facility management system, and you can serve data to any other system like dashboards, space planning, and whatever. Also, some other uses of BIM in FM is the space management. It's very useful to maintain an updated drawings library for the maintenance team, for any other team that wants to use this library. For retrofits, it's perfect. So you always have the existing phase, the new phase. You can make preliminary studies, study costs, alternatives. You can create building use scenarios, like what do you do in a fire, in a flood, some parties or events, how you can prepare this virtually in your model. You can also make renders for visualization, virtual walkthroughs if you want to show your building to people who's not able to go there. And we have also used BIM in our building certifications, who needs very specific or very specialized drawings or 3D representations. For example, our data centers were certified with Uptime Institute Tier 4 and operation certifications. Also for ISO and for LEED certifications, we have made specific drawings with BIM. And in some cases, with historical buildings, you need to use renders and representations to be able to have the licenses and make works on them. Some pictures, the first one on the left is of our data center. So you can see we use BIM to represent with a lot of detail every valve that's labeled with the FM code. So BIM uses the same code as the FM system and is represented for the certification. At the top right, you can see the bus bars, different colors of the data center. It was used to certify to uptime that all the compartmentalization of the data center is done correctly. And at the bottom right, you can see the floor of the data center. And we're using BIM to manage the floor tiles, to see where are the different grills, the grade of openness. Also some pictures of renders. We've used BIM to do wind studies, lighting studies. We've also used point clouds to extract the reality right into the BIM. And we also made a real model of one of our headquarters using 3D printing just directly from the BIM. So the second step is the building analytics, the dynamic data. Okay, everything starts with the BMS, the building management system, who has a lot of input from the building. Meters, the input from the fire and security systems. You have set points from the HVAC control, from the elevators. You have temperature control. And then with all this data, you start building that data model. So the first thing of all is that you have to normalize, to standardize all your data. We used Project Haystack as a reference. So your data is organized. Then you have to hierarchize the data. You start ordering your data by system and by space and by building. So everything is hierarchical. It's necessary to use the same standardization for all buildings. So you have the same rules and the same structure in every building. You don't have to physically change the BMS. That would be expensive to do. You standardize the data that's coming from the BMS. So the result is a normalized building data model, and that's structured by building, by system, and by the different spaces that are inside. So about Haystack, Haystack is an initiative that want to standardize different semantic tags to use for the Internet of Things. So you have any signal, you can apply to it different tags, like you can use in your email. So you can reference that signal using a lot of different tags that give you information about it, and you can organize and search with those tags. Also, you define different control points. You define the unit. You define the range of that signal. So later you can analyze if it's been well measured. Next step, you have to enrich this building data model from the BMS so with a lot of inputs from other places. From BIM, you can extract information, area zoning. From the manuals, you can input all the equipment specs and other data like the utility rates, the cost of the energy, the weather information. And from calendars, you can extract which are the work days, the holidays, and so that's going to affect to our analysis. So about this enrichment, first, you only have to use data you're going to need. You don't have to put everything into the building data model. So if you're going to need something for your KPIs or for your analytic rules, you put it into the model. If not, you don't have to put everything into it. Also, this is a process that's cumulative. You don't have to start with everything at the first step. You can start with a little information or a little part of the building or a small building, and then start growing. So that creates that data model that helps you understand the building, and that's what's happening inside of it. Then, and one of the most useful uses is the benchmarking. With this, we are starting to benchmark different branches with different buildings, so we can know which branches are the least cost-effective, the greater consumers. Also, you can benchmark different equipment between them, or you can benchmark the same equipment during all his life. Okay, next step is adding the FDD&B, the fault detection, diagnostics, and valuation rules, the most important thing. So what are these rules? And we take all this data, all this order data, we upload it to the cloud, where there's an analytic engine. I'm going to use big data technology to extract information from the points. So this engine is going to detect things that are not possible to be detected by a human looking at these graphics. They detect trends, anomalies, relationships between the different signals, and some rules. So once you define a set of rules.
5 minutes, Borja.
Okay, some sparks start to appear. We call these sparks the appearances of these rules. So each spark is defined in a line. So each time these sparks appear, is colored, and you use tags to understand what is happening when these sparks appear. For example, that this fan is not working okay, this office is out of range. Sorry, and you have to value the implication of this spark in euros. So 2 examples. In this building, then the outside air temperature suddenly dropped to minus 50 degrees. Obviously, that was a sensor fault. So, but the system, but the building still worked. So nobody did manage to. But then 2 sparks. We detected 2 sparks. One is that this signal is out of range, and the other was that the anti-freezing system was working even if the building was not in use. So we were able to detect this spark some weeks later. So important thing is the analytics is statistics. So you don't detect them in real time, but you can see at the data into the past and into the future with those sparks. Okay, another example is one building that has programmers that that has an old programming that every hour they started moving the air for 5 minutes, and that was not necessary. So we saw that this intermittent functioning, even on nights and weekends, and that alerted us, and at that point we changed the programming and we started saving. And the last example is a chiller in one of our buildings that was working all the time. And the difference in the temperature was very low, so it was not very efficient. The spark was low temperature difference. So we started, we changed the programming of the chiller and started working on demand. You can see until then that was the energy consumption. When you change the functioning, we start making a lot of savings. So what about the valuing? It's very important to value all these rules because it gives you information in euros, not in kilowatt hours, about what's happening. So you can benchmark in euros. You can see how many euros are you losing by not correcting these inefficiencies. Also, you have to. We are classifying the different rules in different classes. One is controlling the control, see the signals are okay. The other one is the energy measurements, also the site operation to see if we are operating all right the building, or to see if the correlation of the different, so if the pumps are working okay with the chillers or with the fans. So we can benchmark the equipment. You can see if one fan is consuming more than the same fan the year before, so something is happening on this fan. Or maybe you can compare 100 different fans. You don't know what should be its performance, but you can see that 2 of them are out of range. So something must happen with those fans. And also for verification. With this, you can verify if maintenance is being done or the commissioning of the equipment has done just by looking at the graphs. Also, visualization is very important. Nowadays, we have very powerful dashboards, so we can visualize the information in this big data. And I have rounded this because what normally people look at is what is the cost of the inefficiencies in the buildings.
So a minute or two.
Yeah. Yeah. So to end, what are the results of these analytics? First is that it's much more efficient than the energy management system because it can look at the origins, not only at the results. Second is that it's critical to use euros in the analysis of the inefficiencies because that can help focus all the stakeholders and it helps making priorities. Also, modern visualization tools allow for creating very useful dashboards, and you can create different dashboards, one for each user. And the final thing is that by digitalizing the information, you can make a lot of people get into the work and make evidence-based decisions with the buildings. And the third step is look into the near future. What we're working is bringing together those 2 tools. So it's a little video. This is a mock-up of a dashboard that's using information from the BIM and from the BMS and the analytic motors. We're working with our collaborators in creating a panel that so you can see in only one place all the information from the building and with the temporal dimension inside. So this uses information in the next from different sources being ordered and put into the same place. You can see in one place everything you need to know about the building. In there, you have information from BIM, information from your specs, information from the different sparks related to this equipment, and if you select any equipment on the list or in the drawing, so this is the different camps. So you can see everything in one place. So that's what we're working today at BBVA. So to use the data in our everyday life and take decisions based in data. Thank you very much.